So I will be doing my third exam, which is a timer using Arduino and an LCD display. Okay, now let me explain my code. First, I called on the LCD library and initialized the LCD. Then I initialized the buttons and the LED. Then I called pin mode for the inputs as well as the output. I called on a 16 by 2 LCD, and then I proceed to naming some functions. So first is the set time, which would display to the LCD the upper row of the LCD display. So it would display set time, and then it shall display seconds at the 14th column, and the it shall display seconds at the 14th column, and it shall display minutes at the 11th column. Now, this code is made such that the display would be 2 digits for seconds and for the minutes. That means that if the second or the minute is 1 digit number such as 5, then it will um, it will display preceding 0 to the number such that 5 would become 05 or 8 would become 08. But when um, it is a 2 digit number, then it won't display a preceding 0. So this is what the else statement is all about. So the program will enter this code wherein if minutes or seconds is 10, then it will automatically display 10, or if 55, then it will automatically display 55, 45, and so on. So this is for the seconds, and this is for the minutes of the set time, okay, or the upper row of our LCD display. So next would be the lower row of the LCD display, or the timer. So it would display timer as well as the seconds and the minutes of the timer. So it is actually just a repetition of the code earlier. The only difference is that um, the row right now is labeled 1 instead of 0. Okay. So next would be blink second. I decided to make this code since um, I want the user to know that he is setting the minutes or the second when he is using the set button. So when blink sec is called, when the function blink sec is called, then um, it would display a space, or a blank space at the seconds of the set time. So it will repeat displaying a blank space, and then it will display again the, the seconds, the set time and the timer in seconds and minutes. So it would repeat on displaying a blank space and a number, a blank space and a number, until such time that when blink sec is actually called. So next would be the blink min. It's the same with blink sec, but blink min is blinking the minutes. So this will happen. This function will be called when um, when the user is setting the minutes of the timer. Okay, so those are 4 functions that I have made. Then let's proceed to the void loop. So I intend to use goto functions, and since I am using goto functions, I will also use the conditioning that is logic 0 and logic 1. So an if statement condition at logic 0 will mean that the code inside will not be run unless it is called using a goto function. So this is the label of my goto function, press start. And this label indicates that this is when the start button is pressed. So when the start button is pressed, actually, um, my initialized variables are set to wherein the minutes of my set time is multiplied by 60 and added to the seconds of my set time. This would give the value of st as the total seconds of the set time. Okay, so this is done such that um, we will have no difficulty in knowing how many seconds are there all in all in the set time. So this is done to merge minutes with seconds. Okay. So then a while loop is being made, wherein while the time or the timer is less than the set time, then the timer will increment its value. So t plus plus it's equal to t plus 1. Okay, t equals t plus 1. This is t equals, so that's just the same code. Then the minutes for the timer is given with a value t minus quantity t percent 60 uh, all over 60. Okay, so this t percent 60 is a modulo function. So if you type this function, if you type this operand percent, then it would divide the value of t with 60 and would return to you the value of the remainder of that division. Okay, so if you return the remainder, then you subtract t with the remainder, then it will give you a value that is divisible by 60. Hence, min t will still become an integer, such that it's the same with what you have initialized. Min t is an integer. Okay, so next is the sec t. Sec t is for the seconds of the timer, and that would have an equation of t modulo 60 or t percent 60, wherein it would give you the remainder when t is divided by 60. Okay, then we display set time and timer. We call these functions again. Then if the set time is not equal to the timer, then we'll have a delay for this while loop equal to 1000. Actually, you can decrease this 1000 delay because um, there would be seconds, there would be milliseconds that that would be cost when you implement this code, such that when you make your timer, the 1000 delay is not anymore 1000 millisecond delay is not anymore true for your LCD display, because this code will run using some milliseconds. So for you to accurately measure the second per second increment of this while loop, then you should lessen your 1000 millisecond delay. So you can approximate actually 990, 9999, 999, somewhere less than but close to 1000 delay, that is somewhere less than or close to 1000. Okay, so the delay will happen for as long as st is not equal to t. Okay, but when st is equal to t, then there won't be no delay, and the while loop will um, automatically be done, and the program will proceed to the next um, code, which is an infinite while, while 1. So the infinite while is encoded with a digital write red LED high, and then a digital write red LED low. So this would make the LED blinking, and I put in between the blink sec and blink blink, such that the seconds and the minutes are also blinking together with the LED. I didn't put delay in between this blinking because blink sec and blink blink already has a delay in their code. Okay, so the blinking will not be too fast for you to, or for the user to not see. Okay, so this infinite while loop will be broken if and only if the user is going to press the set button. If you were wondering why is it low, the my closure circuitry is actually connected such that if a button is pressed, then it will give a logic low. If the button is not pressed, then the digital read will actually give you a logic that is high. Okay, so low is checked here whenever the button is pressed. So when the button is pressed, um, all the initialized variables will be set back again to zeros, and the whole program will go to press set, which is not yet prepared. So uh, we'll now proceed to declaration of the press set. So this is another while and infinite while, and the program will actually automatically go to this infinite while loop because this if statement is 0. So the program will not go there, while this is 1, the logic 1. So the program code will go directly here. So press set, um, it's a go-to label that will be called whenever I go to function here. So if I go to your press set, so this press set will automatically um, run the program here. Okay, so when set is pressed for the first time, then display set time and timer, and I do the delay since this is where you expect for a start button or a set button. So when the start button is pressed, actually the code will send you to press start. Okay, so it will send you here inside the if condition at 0. Okay? And it will deliver this codes. When the set button is pressed, okay, the set button is pressed for the first time, um, the program will enter another infinite while loop wherein you will display the seconds in a blinking manner, indicating that the user is setting the seconds. And this if statement for an increment button being pressed is for increment of seconds. Second ST plus plus is equal to second ST is equal to ST plus. Okay. That code is this code is just equivalent. Okay. So however, when we view in our watches other digital clocks, seconds will actually not have a value that is greater than 59, right? So when seconds is at 59 and other second will pass by, then you'll notice that minutes will increment. But since we're setting seconds here, so for convenience purposes of the user, when seconds is greater than 59, then seconds will go back to 0. Okay? And when the decrement button is pressed, seconds is decreased. Seconds, sec st minus minus, that's the same as this. Only that the plus sign is the minus sign. Okay? If second st is less than 0, then sec st is equal to 59. And this is when the decrement button is pressed while sec st is less than 0. So it will display 59 for the seconds value. Okay? So that's it for setting the seconds. And if the set button is pressed again, so it will enable the user to um, um, set the minutes. So this is for the blinking of the minutes, and this code is the same as the previous one, as you can see. Wherein low, wherein the only difference that is checking and changing the minutes of the set time. Okay, so within this infinite while loop, when the set button is pressed again, then the whole program will just go back to press set. So if you are inside press set, then you can actually opt to press the start button or reset button. If you are outside this press set, or if you are actually currently setting, you can't actually press the start button. It won't enable the timer to start because the user is still setting. Okay, so the start button is the same. So that's all for my code, and let's proceed to the next step. Okay. Now if I press set, the seconds will be blinking. I decrement it would be 59. I increment it would be 0. So for the purpose of running this program, I would just set the set time in 5 seconds, click set again, then I will be able to change the minutes, as you can see. I increment it, increase or decrease it, using the then if I press set again, then the time is being set. And as I press start, timer runs for every second, arrives the set time, then LED will be blinking as well as the seconds and display. So if I press again set, then it will reset. So it went back to 0. Okay, so that's all. Thank you.